Okay, so this is what the periodic table of the elements will look like when you are doing your exam. Okay, so that's why you have to know the first 20 names and symbols, because you're not actually given the names corresponding to the symbols. Okay, so that's why I got you to learn that. Now, just if we look at what we have here, this is, and I'm just going to use in my notes, in my PowerPoint, I have done aluminium as an example. So I'm going to go up here to aluminium, and aluminium is Al. And if I look at Al, I can see that's its symbol, okay? And I have an atomic number of 13, and I have a mass number of 26.97, okay? So I have two numbers. The symbol with the two numbers is called the nuclear formula. And if I look, every single element on the periodic table has its own unique nuclear formula. We can see all the numbers on top are different, okay? So this is my nuclear formula. If you look, I have a symbol, and that identifies the element that it is. The second thing I have is I have a smaller number. And the smaller number is always called my atomic number. Okay? I also have a bigger number, and that bigger number is called the mass number. Okay? You need to know the definition for both of these. The atomic number, so if you're asked what is the atomic number is the number of protons in an atom. Okay? The mass number then is the number of protons and neutrons. Okay, so my atomic number is the number of protons, my mass number is the number of protons and neutrons. What we are going to work out for aluminium and for every single element is the number of protons, the number of neutrons and the number of electrons. The first thing I'm going to look at is the mass number here. And if I look at my mass number, I can see that it's 26.97. And with these mass numbers, they're very rarely whole numbers. So what you're going to have to do is round it to the nearest whole number. The nearest whole number to 26.97 is 27. Remember, if the number after the decimal point is less than 0.5, you go down to the nearest whole number, whereas if the number after the decimal point is greater than 5, you go up to round. Okay, so that's 27. So what I have here is aluminium with an atomic number of 13 and a mass number of 27. I know my atomic number is my number of protons. So straight away, that means I have 13 protons. Remember, my protons are positively charged. So every single atom is neutral. So if I have 13 protons, I must also have 13 negatives. And remember, my negative particles are my electrons, and we've looked at this already. So my number of protons is going to be equal to my number of electrons. If I have 13 pluses, I must have 13 negatives. So if I have 13 protons, I must have 13 electrons. So I get both of those values from my atomic number. Then I'm going to look at my mass number, and my mass number here is 27. And if I look at my definition, it is the number of protons and neutrons equals my mass number. Okay, my mass number is my number of protons and neutrons. I have already worked out from my atomic number that I have 13 protons. I know my mass number is 27. So any of the remaining number must be neutrons. So 13 plus what gives me 27? 14. So I have 14 neutrons. Okay? That is how you work out how many protons, neutrons and electrons every atom has. You have to know this. If you do not know this, you will not be able to answer these questions, because you have to know how to work out your number of protons to be able to work out your number of electrons, and then you have to know that your protons and neutrons gives your atomic mass number.